hello, everybody. Thank you for having me here today. It's a pleasure being at Lidar CANEX 2023. My name is Gaspar, and I am the Senior Channel Partner Manager for the Americas at NavVis. And well, I hope you guys have a good time today, and hopefully you're going to learn something more about us, about NavVis, and maybe we will help you driving your future on this magnific industry of reality capture, right? So we're gonna talk about Islam technology and the future of laser scanning. So a brief introduction about myself. I'm in the fields of geomatics for a little bit over 25 years now, involved with laser scanning and photogrammetry since earlier, 2000-ish. I'm a land surveyor and civil engineer, and I work with a mission to democratize as much as possible technology for better decisions in all verticals of the geomatics. So brief about NavVis now. Well, NavVis is a German company based in Munich. It's a company, it's a young company. We're going to the 10th anniversary this year. But we have thousands of customers. We are present in more than 40 countries. We sell globally through our resellers or direct sales. We are today 380 around employees, which about 50% of those guys are actually 100% focused on engineering and development, right? So again, our main office is in Munich, but we also have 2 offices in the US where we sell directly. Talking a little bit about our technology. So, we develop solutions for the 3D representations of the world, right? That the representations of buildings become a classic deliverable for LSP, enabling several use cases from AEC professionals and the end users. And managing the entire life cycle of a building has never been easier, of course. So thinking of that problem, NavVis introduced it a few years ago, a solution that's composed by a piece of hardware to do the reality capture, right? All the data acquisition in the field, and of course a software for data management, processing, filtering, alignment, everything we need to do with a point cloud, and then bringing it to a collaborative platform, right? So our workflow is quite comprehensive. We go from the data capture, doing everything that is needed to build up a whole accurate and high quality point cloud that represents the environment around you, and then we go from construction, verification, collaboration, handover, as built documentation in a variety of verticals. So coming back to the theme of this presentation, which is Islam. Right, so we're talking about Islam technology, how it impacts the future of laser scanner. So for those of you that are not aware yet, so Islam means Simultaneous Location and Mapping, which is actually an algorithm, right? So this is actually a piece of software that is capable to convert in real time all those raw measurements from different devices, different sensors, measure the environment around yourself, and find your position in that environment, right? So basically, the most important piece is that the accuracy of Islam solution, it does not depend, or let's say it depends very little from the hardware that you're using, but depends very much of the accuracy of this trajectory process, right? So it depends much more on how accurate is this algorithm able to process this trajectory, track Z down, right? Tracking it down. So as you move, you start scanning the whole surrounding, right? And the algorithm finds these pieces of geometry around you and hold itself on those geometries, right? Whatever it is. If it's indoors, it could be in the corners, between two walls and the ceiling. If it's outdoors, it can be, facades or poles, curbs, whatever, walls, right? Whatever is outside, outdoors. And actually stitch the next step, right? As you move, stitching in real time, this kind of cloud to cloud alignment as you go, right? So basically this is this lamp, which again is a software. That's why we used to say that the new era of mobile mapping is completely driven by software. And that's why NavVis is actually a software company, right? So let's talk a little bit about quality. I think this is a recurrent, subject that always comes when we're talking about new technologies, or if it's not that new, at least for you, but maybe a new approach in our industry, right? So we're talking about quality. So let's start it checking this nice, clean terrestrial laser scanner, right? So we used to call TLS, terrestrial laser scanning, is used for the scanners that goes on a tripod, scanners that, they do static measurements, right? So let's talk. Let's check this data very quickly. And I took I took some time to put some adjectives here that are usually used to describe this, right? So we're talking about crispy, a sharp point cloud, accurate, dense point cloud. It's a beautiful point cloud once we see everything finalized, aligned, the 200 stations that you have there, 200 positions. Once you put it together and spend some days doing that alignment, you will see this amazing point cloud, right? Which is, by the end of the day, very beautiful. And of course it is, and it's also sharp, crispy. You can see all the details as you can see here, right? So details on the grass coming, on the top of the curb. You can see the curb very well done. Every single software on the market that does automatic extraction can easily extract this curb, right? If you go to the image on the right, you're going to see a nice facade that shows you, we can even read the number here, right? I'm going to give it a zoom and you can see it's 306. That's a beautiful, you can see all the colors, every single detail here, right? And that's great. But what if, and just what if, I tell you that this is actually data from NavVis lab technology and not terrestrial laser scanning? Would that blow your mind? So this is specific data set that I'm showing you. We collected that in about 5 minutes, just walking down the street, right? It's in a small city called Trois-Rivières in Quebec. And you can see it's a nice, sharp, crisp, beautiful, dense, right, data. And everything was done as you walk, as you move, with NavVis technology for acquiring the data in the field using the VLX, which we're going to talk soon, and processing that data through our software IVIOM. Right? So we not only process the data, we process the data, we massage that data, we apply more than 40 filters to this data. We apply all the beautiful images to this data. That's why I want to, beforehand talking about the piece of hardware that collects it or how we do that, I want to show you some nice examples, right? So probably presenting some point clouds captured with the NavVis VLX. So look at this data, right? So first of all, keep in mind that we deliver a point cloud with a final resolution up to 5 millimeters. So that means that you're going to have 1 point every 5 millimeters in the point cloud, right? And you may say, okay, that's good resolution and the color, it's definitely good, but it Is it fast? Oh yeah, super fast. Okay, but is it accurate? Well, it's accurate enough for 80% of all surveying jobs. Everything that a surveying company or a laser scanning service provider need to do, VLAX and Ivion can do 80% of that. What's the accuracy? 6 millimeters. Okay, so for every single job that you may have there that demands that 6 millimeter would cover, let's say, right? If you have a requirement for a project where 6 millimeter covers it, it's going to be fine, but 10 times faster. 10 times faster in the field and tons of hours faster in the process, from the processing side. So that's another example. You're going to see a very quite complex, oil and gas equipment there. We can see every single vase, every single detail was scanned. And this, by the way, if you go to YouTube, there's a nice video about that there. If you want a piece of this data, just ping me and I can easily send that to you. You're going to be amazed. This is another example, right? So look at how, for those that comprehend a bit about or understand a bit about dynamic systems, right? You understand that to be able to achieve this result, even on the color side, even talking about the colors, right? The trajectory must be computed very, very accurate, right? Why? Because you don't see the blue coming over the gray area. You don't see the gray area coming over the green area, right? If you look here, you see physically the difference, geometrically difference between the vertical and the horizontal, but you don't see colors getting messed up, right? So that means that the trajectory is very, very accurately computed. Last part of the details here, some other details about vertical sections, door frames, stairs, and handrails, elevator doors. So you can see a little bit more about the detail that our users can achieve after post-processing, right? Which, by the way, it's done completely 100% automatically and overnight. So we're talking about the era of mobile mapping. We're talking about being at least 10 times faster. We're talking about having a much greater coverage than a terrestrial laser scanning system, right? You understand when you go to a room, you may put a tripod in the center of the room, you do one scan, right? But here, you actually walk around the room. So if there is a table, a desk there, you just go around the desk, right? And also you take photos. And those photos are used not only to colorize the point cloud, but also to create this whole experience on our web sharing platform, right? Which is the virtual tour, your own Google Street View experience, right? So the coverage is much better because, of course, if a TLS would have to have the same coverage, they would need to put the tripod every 1 meter, right, or 2 meters. Nobody does that. So in terms of speed, that's why we are at least 10 times faster, right? So the NavVis VLX second generation. So now we're talking about the hardware. So how do we do that, Gaspar? How do we create this amazing, point cloud? So, well, everything starts from the field. Everything starts in the field. Everything starts from collecting data, right? So we're talking about the revolutionary wearable mobile mapping system, right? So this system was designed with 2 components lidar. So you have one vertical lidar and one horizontal lidar, right? Those lidars, they are collecting 300,000 points, each one of them, and they are collecting this in opposite axis. So as you move, you literally swipe everything, right? You literally scan everything vertically and horizontally as you move, right? Another piece of sensors that we have here are the cameras. So we also contemplate 4 cameras around the scan head, which are triggered synchronized. So once you take a photo, you actually take 4 photos, front, back, left, and right. And those photos will later be processed in one big panoramic image, right? and this panoramic image will compose the bubble views. That's what you're going to use for the street view experience, right? Which obviously can also be indoors. And also, those are the images that we will apply over the point cloud to colorize and make those beautiful images as you saw. Of course, everything is processed. It's scanned in real time, and part of the process is already done in real time. So as you move, you can see this top view on the screen that allows the user to be sure that he covered everything he needs to cover. Right, you don't leave the site without having 100% sure that you actually covered everything you need to cover. This is a little bit of a workflow. So basically, we start capturing data. You may also use a third-party sensor to capture data from a tripod, drone, something like that, in the same project. But by the end of the day, what you do with the VLX is that you're going to upload this to the cloud. So our software solution is 100% on the cloud, which brings us at least 3 advantages, right? First, you don't need to put $20,000, $30,000 in a computer to process all this data. Second, you don't need to stay in front of this computer doing alignments, finding targets, common points between scenes, and all of that stuff that's quite common for people that work aligning tons of laser scanning data. You don't need to be there. Everything will be done automatically. The third one is that keep in mind that because it's so fast, our customers they use it to finish 2, 3, 4, 5 scans in one day, right? So even if you had a very expensive computer, and even if you were able to process this on your desktop, you still would process these projects one at a time. But using the cloud, what happens is that it's not in sequence. The process is actually parallel. So by the end of the day, you upload 5 of them over there. Maybe it's going to take 5, 6, 8 hours to process one, but it takes 8 hours to process 5 because you're going to use multiple computers, right? That's the main 3 points that I see, as a professional in this industry as well, as very strong points for the cloud. So once is uploaded, right, the cloud processing is going to happen overnight, and the next day you have everything processed, aligned, colorized. If you use it control points, of course, everything can be georeferenced if you want. If you use the control points for georeference, you're going to get a residuals report with residuals, for every single point, and everything that you need is there. If you need to start creating deliverables from the point cloud, what you do is that right there, when the process is done, you download the point cloud, send to whatever software you're going to use. We have some partnership with some softwares like Revit, Autodesk Cloud Construction, Aviva, ClearEdge. We have some plugins with those softwares to kind of close the workflow, right? But so you downloaded the point cloud and you start doing whatever you need to do with that, but you also can push it to our web sharing platform where you're going to actually publish it and collaborate, right? So now I'm going to run a quick video because videos are much easier to make you guys understand the whole process. So basically, you start with collecting data in the field, wearing the VLX, and just walking. Right, you walk in a normal pace. If you have coordinate references, whatever control points you have there, we can use. It doesn't require any special targets, spheres, material, or prisms or whatever. Every single point in the ground or in the wall that you have a coordinate can be used, right? So once we collect all the data, oh, by the way, we don't need the coordinate right there. We just need the coordinate when we go to the website, to the platform, and we create a new website, right? A new project. So when we create a new project there, you can specify if this is in a global coordinate system. So we support all of them, right? And basically, you're going to drag and drop the files there. prepare its processing tasks that takes you 30 seconds, right? Put the control points there if you use it. Put your email and go home. Next day, everything is processed. If you have different scan sections, or if you want to bring your data from the drone or from the third-party, another TLS, another scan on a tripod, that's where you're gonna do the alignment, right? We have an automatically cloud to client alignment. And also in the platform, you can take measurements, you can create points of interest, notes, you can mark people there, you can download just a piece of that content and share this whole database with the team with the goal to take decisions faster. Well, last but not least, I want to introduce you to our reseller in Canada, which is Cancel Surveying Equipment. So if you need more information, if you want a demo, if you want to run a proof of concept, if you have a project in mind that could be use it with our technology, with NavVis technology, feel free to reach out to Cancel. They are spread around the country with different branches. I'm sure one is near to you, so make sure contact your account executive at Cancel, or just reach out to them through the main website, and they will be with you talking about our technology and our products. Okay. And finally, we go to the QA. So that's it. I hope you guys have enjoyed, and let's talk now. I hope you have some good questions for us to keep the conversation. Thank you very much. It was a pleasure.
Hello, Gaspar. Excellent talk. Thank you so much. That was very, very informative, very nicely done. You're muted. What is the range of your scanner, and does anyone ever put these on vehicles?
That's interesting. It's a recurrence question that often comes up. So so the range of the sensor itself is actually 100 meters, but
Okay.
But for us to be able to deliver the 6mm accuracy that it's in our spec sheet, we cut that up to the max of 50 meters, right? So, but keep in mind that since it is a dynamic system, right? So it's 50 meters from the trajectory. So it's basically, 50 to the left, to the right, front, back, up and down. And of course, as you move, we increase the covered area, right? And regarding the possibility of putting, putting it at a vehicle, see, the VLX was designed for the human body with the human speed, even let's say correcting this kind of trajectory that we do when we move. We may don't see that, but when we walk, we describe a trajectory that goes like that, right? So the whole system was designed to compensate this sort of movement. And our IMU, which is inside the hardware, right? It has a certain level of sensibility that will stop correcting data if you put that on a car and it's too bump, if the road is too bump or something like that, right? Also, keep in mind that if you put that the VLX on a vehicle and you start running at, I don't know, 20 kilometers per hour, 40 kilometers per hour, it's going to affect the resolution, because the distance between lines, it's going to be much, much higher than at the speed as we walk, about, I don't know, 4 kilometers per hour or so, right? So there is, even if you put that on a smooth floor, let's say, smooth floor, you put that on of those segways, smooth wheels, and go on top of this, and you just run on the smooth floor, it probably is going to work, but not with the same result as if you would walk, right? In terms of resolution, in terms of accuracy, right? We need that density as well. So if you increase the speed, we lose density, just specifically because of this distance between lines, across trajectory, right? So yeah, it may affect, for sure it's going to affect the accuracy. But if it's smooth enough in a super lower speed, you may get some result, but we absolutely not suggest it. The system was designed for the human body, right? If you put that on a vehicle and go to the street, it's not going to work. That's fair and clear answer.
Okay, well, great, thank you. We have another question from Matthew Wong, and I would say he's got some experience with laser scanning by this question. Any tips or guidance to map a narrow tunnel or uniform environment? Example, tunnel, things like that. So I guess the challenge there is just like in photogrammetry, uniform area, hard to really get unique points.
Featureless, right?
Yes,
that's the issue. Well, yeah. Keep in mind, I think at this point, people start understanding that Islam, one of the limitations of the Islam is the surroundings. We need some feature to hold on to, right? So in this kind of environment, tunnels or long corridors, or let's say hospital corridors where every door has the same distance, there's nothing different on the corridor. So in this kind of case, what happens is that, you have the left wall and the right wall, and those walls, they will hold displacements. Let's say, they will constrain movements in this plane, right? The floor and the ceiling will kind of hold, displacements, and we work as a constraint in vertically, right? So you have the ceiling and you have the floor holding, but along the corridor, or along the tunnel, because everything is so similar in terms of geometry, it's very easy that this lamp can get, lost, and maybe make it longer or short, right? So it will be constrained in that space, but along the corridor or along the tunnel, it usually happens. So there is a limitation there, depending on how long it is. I have customers that, they've been doing that for short corridors or short tunnels using control points. So specifically about like hospitals, schools, big, environments like that indoors, people use control points, at least like one at every corner. If it's a big like O-shaped corridor, right? So you have a big aisle here, and then, like connecting different rooms and whatever. If usually, again, it depends, of specifics of the project, more how long it is and how big it is. But if you use control points, it's going to work. Now, tunnels are a little bit more challenged, because I'm telling you right now, if you have like a 3 kilometers tunnel shape, featureless, and you even using control points, probably the result is not going to be great. It's not a great. It can help you with some like shadow areas when you have a second device there doing something, and you have shadow areas. Oh, I need to grab this, 100 meters here, may work, but a long distance, it's.
Gaspar, I think you've muted yourself again. No.
Oh, I'm so sorry. Okay.
There you go.
Good. Yeah. So I just saying, if the corridor is too long, basically, or the tunnel, it's a limitation for short ones. We can use control points, and it usually work, right? You just need more control points.
So could one also consider, instead of control points where you're actually trying to get coordinates, could you just put some sort of unique markers up along the tunnel? Would that help with the slang?
Yeah, absolutely. I was just listening for a customer that he had a good challenge scanning like an old facility, like industrial facility, but he also need to scan the outdoors, the surrounds of that, which is kind of a big parking lot with nothing else. So he ended up by himself parking the cars of the crew and dropping some box, like cardboard box, card box, just dropping different ones there, and he got it. He didn't need the 6 millimeter for the parking lot, granted, but he ended up with a very good alignment, probably, around the centimeter or so. But that's a good point. If you if you put something there that creates that geometry that this lamp need, yeah, then we are back in the game.
Okay. Thank you. This next question, I think you've sort of somewhat answered it, but maybe you want to add to it. What solutions do you have for avoiding slam drift?
Yeah, again, this lamp drift. Well, there is different, let's call it components there, right? The first is the algorithm itself, right? So there is, better slams and worse slams, right? So it depends on the algorithm. What I'm saying maybe doesn't work for every single slam solution in the market, right? But NavVis slam algorithm is very, very solid. And it helps a lot in challenge environments where people that is used to use another slam had difficulties, or it was impossible with our slam. The behavior was much better and he could get it done, right? But definitely ContraPoints, or as we mentioned, dropping something in that area helps with the drifting, right? Also, obviously, there is a proper what we call best practice, right? So, every time we talk about this lamb, we talk about the specifically way to do that covered area, right? So this lamb basically needs to see at least part of the environment twice, part of it. I don't know, 2%, 5%, but we need to see that twice. So if you just pass along a big hall, and you don't come back, it's not a good thing, because we only see that, the whole geometry once. But if you enter in a big hall and you do a loop and you close that loop, so part of the geometry is being seen multiple times from different angles, right? And that's what also helps us, because we have 2 lidars and not only one. So we have a much more covered area, so we see the same features multiple times from different angles, and that's what helps us.
Perfect. Okay, this next one, I think your last demonstration really answered this question, but would this equipment work outdoors in a forested environment? I think the answer must be yes.
Yeah, as I used to say, leaves, pardon, leaves on a windy day, they are a challenge, right? So I always, take care about saying, yeah, it's gonna work, because, but honestly, it depends. We have customers doing projects in forests where you see a good amount of the tree itself, the big chunk of wood, which is much more stable, and less of the leaves, dancing in the wind. So that part, it's not static, it doesn't help much. But if you have more data, or if you have enough data on the static part, it's going to work. Yeah.
No, that's a great point about the leaves. Great point.
It's always.
The next one here is SLAM for indoor is good, but what do you suggest to include for the outdoor textural data facade to make the structure? So let's say you do the inside of a building. Obviously you can get the outside walls, but maybe not the roof and things like that.
Yeah, so that's a question where, it's a common question as well. People use it in the way that SLAM was brought to the market. We include ourselves there, right? We changed the VLX. That's why this is the 2nd generation, because of that. So the way that the SLAM was introduced to the market, it was for an indoor solution, right?
Right.
And what happened with us specifically is that at some point we had a great number of customers also working outside. And then we start thinking, oh, okay, people see value scanning outside with the VLX. And then we actually changed it a little bit, the VLX from the 1st generation to the 2nd, and made it even better. So now I can comfortably affirm that at least 70% of our customers, they do indoors and outdoors. We have a big portion of customers that do a lot of much more outdoors than indoors. We have right now I have customers in Canada doing cadastral topographic surveys, right? Specifically outdoors. So the technology changed it a lot. We changed our hardware, and we adapted our algorithm to respond very well to outdoors as well. So I would definitely invite you that made this question, or if you have interest in that, to come to our workshop tomorrow. We have a great project to show to you guys tomorrow in our workshop at Lidar CANEX as well, where we're going to be showing, you know, outdoor and indoor combined data, georeferenced, you know, and with all the challenges that an outdoor, you know, brings, including, you know, sunlight and the geometry of outdoors and everything. So definitely, I can tell you that our technology today responds quite equally good as indoors and outdoors.
Okay, great. So you mentioned georeferencing there. So that leads us to another question in the chat here. And I have a quick preamble question to that. I noticed using the device to actually physically touch the control markers, either on the wall or on the ground. So just before I ask Matt's question, can you also pick control points in the point cloud after the data capture? For example, let's say you couldn't get up to an area, but yet you knew the coordinate.
Yeah, so not as part of our workflow. Our workflow, which is when I talk about our workflow, I'm talking about, you know, the automatic alignment and georeferencing and everything. So everything that we do from our side with point cloud, there is no extraction of, you know, like people are used to see spheres or, you know, special targets with special materials made. And then we extract that automatically from the point cloud. No, we don't do that. The way that VLX collects control points is actually touching it, as I showed in that video, right? So we physically touch that, and because we know all the offsets to the center of every single sensor, so it's everything tied up, let's say, dimensionally, right? So we basically transfer that coordinate to the center of the lidars, and then from there we compute every single coordinate. So we need to touch it during data acquisition, right? Once it's processed, you have nothing else to do there. Of course, you can download the report and check the residuals for every single point. Actually, the software also does a quick check before starting the processing. It does a geometrical check just to make sure that you input the right coordinates, right? But yeah, if you need to do that, if you need something after that, you need to definitely download the point cloud and bring to a different piece of software. Yeah. Okay. No, so but we don't need.
Thank you. In that regard, Matt's question was, what accuracy can you expect when you georeference your scans?
Sigma 1, it'll be almost 1 millimeter better. You know, so there's no magic. That's the truth. Dynamic system will not achieve the super high expectation that we have in terms of accuracy as a terrestrial laser scan, right? And for that, we are always very transparent on that. You should use the right tool for the right job, right? And that's why we say that we can do 80% of the job. If 20%, what is that 20% that we cannot do? Everything that needs more than 5-6 millimeters, okay? So we're talking about what? We're talking about deformation on a wall. I need flatness on the floor. You need 2 millimeters, 3 millimeters. You need a static laser scanner, right, for that. And of course, there is other components on that. It doesn't matter if you have a static and then you put 300 scans together, only the alignment error will be 2 centimeters, right? So, but you know, assuming that everybody knows what they're doing, if you need higher accuracy, you need to go for that. We spec 6 millimeters, okay? Usually, if you add a good set of control points in a regular distance between 25, 30 meters, no more than 50 meters apart, in a good geometry as well, right? The control points, you will get better than 6 millimeters, but not better as 2 millimeters. It's going to be between 5 and 6, okay?
Okay, perfect. Yeah. Thank you very much for going into details there. We have a question from Martin, who is a longtime expert in LiDAR. How does SLAM scale to larger outdoor areas, 100 acres, 1,000 acres. At some point, does it become inefficient to use? And obviously you've set the stage already to say this is a device made to walk.
Yeah.
So
yeah,
I guess.
and that's that's a great question. And it's always coming back to what I said. The VLX is one more tool in your toolbox, right? I can tell you by experience, the customers that we have that deal with projects this big, they use a hybrid solution. So those guys are using either a drone or a big mobile, the mobile that goes on a car, right?
Yeah.
And then we scan the whole city, right? Right now we have customers that they scan cities and they use the VLX to cover all the shadow areas, right? They're just driving the city and there is a line of cars parked that they can't see the curb, but they need to get the curb, so they go to VLX, right? That's a good. So it's the profile of our most successes customers. It's a hybrid profile. It's a hybrid project. The guy is using let's say a TLS or a drone or a big mobile and the VLX, right?
Yeah.
Unless he's very focused on one application or two, he doesn't do he's not open to do everything. This guy got a big contract and he's doing 100 or 1,000 stores or something. Then he's doing specifically that, right? So it scales at some point, but not that much, right? That's
very good. Great stuff.